Today we will start the LPC2148 Uart 0. That means the Uart is the universal asynchronous receiver transmitter. Is a serial communication protocol in which the data is transferred serially bit by bit at the time. Asynchronous serial communication is widely used for that the byte oriented transmission. In asynchronous serial communication, a byte of the data is transferred at a time. Uart serial communication protocol used for the defined frame structure for their the data bytes, and that is the frame structure is the asynchronous communication consist. Whereas the start bit, it is bit which indicates the serial communication has that the started, and it is always is the low. Whereas communication has started and it is always start bit is the low. The data bits packets, the data bits can be packets of the 5 to 9 bits. Normally we are used for the 8-bit data packet, which is always sent from that the start bit, whereas the start bit is always low, and that the stop bit, this is usually used for the 1 or 2 bits in the length. It is sent after data bits packets to indicate the end of the frame, whereas the stop bits is always logically high and the start bit is always low. Whereas the asynchronous serial communication usually for that the frame of consist start bit, that is the 1 followed by the data byte 8 bits, and then that is the stop bit which is formed at the 10-bit from frame, in that shows the figure. Whereas the frame can be consist of the 2 stop bits instead of the single bits, and there can be also be the parity of the bits after that the stop bits. Where LPC2148 Uart has the 2 inbuilt Uart available, whereas the Uart 0 and Uart 1. So we can connect the 2 Uart enabled device there as the GSM module, GPS module, Bluetooth module. With the LPC2148 at a time, Uart 0 and Uart 1 are identical, other than the fact of the Uart 1 has the modem interface included. The features of the Uart 0 is the 16 byte of the receiver and transmitter FI/FOS, that means the first in first out, whereas the built-in the fractional baud rate generate with the auto bauding capabilities, whereas the software is the flow control, then the TXEN bit, that means the transmit enable bit is the registers, whereas the features of the Uart 1 is the 16 byte of the receiver and the transmit FI/FOS, whereas built in the fractional baud rate generate with the auto bonding capabilities. The Uart 1 is the software and hardware flow control implementation possible, and the standard modem interface single included with the flow control, that means the fully supported in that the hardware. That is the LPC2148 Uart pins. In that the Uart 0, whereas the output pin is the TXD0, that means the serial transmit controller, that is the serial transmit data pin, and that the RxD0, it is the input pin, whereas the serial receiver data pin. In that the Uart 1, the TXD, that is the output pin, it is the serial transmit data pin, and the RxD1, it is the input pin, whereas the serial receiver data pins, and that the RTS1, it is the output pin to request the send signal pin, and that this is the pin is the active low signal indicates, whereas the Uart 1 is the would like to be the transmit data to the external modem. CTS1, it is the input pin to clear to send signal pin, and that is the active low signal indicates the external modem, whereas ready to accept the transmitted data, while the TXD1 from that the Uart 1. There next is the DSR1, it is the input pin, whereas the data set ready to signal pin, and that is the active low signal indicates if the external modem, and the ready for that the established communication link with the Uart 1. Their next pin is the DTR1, that is the output pin, whereas the data terminal ready to the signal pin, it is the active low signal indicates that the Uart 1, and if it is ready to the established connection with between the external modem, and that the D1, it is the input pin, it is the data carrier detect signal pin, it is active low pin, and that the external modem established the communication link with the Uart 1, and the data may be the exchanged. The next pin is the RI1, where the input pin, that is the ring indicated signal pin, whereas this is the pin is the active low signal, and that is the telephone ringing signal has been detected by that the modem. We will see the how Uart T0 here, and the Uart T1 can be used in the similar way by the corresponding register that for the Uart T1. In that the Uart T0 register, the first register is the Uart T0 receiver buffer register. It is the 8-bit read-only register. This register contains the received data. It contains the oldest received byte and the receive for that the first in first out. If the character received is the less than 8 bits, and that unused for that the MSB are that the padded with 0. The divisor latch access bit is the U0 LCR must be 0 in order to access that the U0 RBR, that means the 8-bit data read-only registers. The second register is the Uart 0 transmit holding register. It is the 8-bit write-only registers, and data can be transmitted is returned to the registers. It contains the newest received byte and the transmit for that the FIF0. The divisor latch access bit is the must be 0 in order to access that the U0 THER. The next bit is transmit register is the Uart 0 divisor latch register, that means the U0 DLL and the U0 DLM, where U0 DLL is the divisor latch LSB and U0 DLM is the divisor latch MSB. These are register 8-bit read or write registers, where are the Uart T0 divisor latch holds the value by which is the peripheral clock, that means the PCK CLK will be divided. This value must be 1 by 16 times and the desired baud rate, whereas the A0 into 000 value is treated like to the 0 into 001 value. It is division by the 0 is not allowed. The divisor latch access bit is the U0 LCR must be 1 in that the order to access the Uart 0 divisor latch. The next register is the Uart T0 fractional divider register, where it is the 32-bit write register. It decides the clock prescaler for that the baud rate generation if the fractional divider is active and the DLM is the 0, that means the DLL must be greater than 3 times, where if the DIVA DDVAL, that means the fractional registers is 0, the fractional baud rate generate will not the impact for that the Uart 0 baud rate, that means the reset value of the DIVA double DVAL is the 0, where MUL VAL must be greater than the equal to that the Uart 0 to operate that properly, and regardless of the fractional baud rate generate is used or that not. The reset value is the MUL VL is 1. The formula for that the Uart 0 baud rate is given by MUL VAL, and that the DIVA should have that the values in range of the 0 to 115. That means if it's not ensured, the output of the fractional divider is undefined. That means the value of the U0 FTR should not be modified while that the transmitting receiving data. This may result for that the corruption of the data. The next register is the UART0 interrupt enable register, whereas this register is the 32-bit read or write register. It is used to the enable UART0 interrupt sources, whereas the DLAB should be the 0. That means the bit 0 RBR, that is the interrupt enable, but it also controls the character receiver timeout on that the interrupt, where bit 0 RB R is 0, there is the disable receiving data available in that the interrupt, and whereas the bit 0 that means RBR is 1, where this is the enable receiver data available in that the interrupt. The next is the bit 1 is the THRE interrupt enable, where this bit is the 0, the disable for that the THRE interrupt, and where this bit is 1, there the enable THRE interrupt. The next bit is the bit number 2, their bit is the RX line interrupt enable, where bit number 2 is 0, there is the disable UART 0 RX line status interrupt, and that this bit is 1, the enable UART 0 RX line is the status interrupt. The bit number 8, that is the ABEO interrupt enable. This bit is the 0, there is the disable auto baud rate timeout interrupt, and there is this bit is the 1, the enable auto baud rate timeout, or that is the interrupt. The bit number 9 is the ABT0 interrupt enable. This bit is the 0, the disable end of the auto baud rate interrupt, and this bit is the 1, the enable for that the end of the auto baud rate interrupt. Whereas the next 6 number bits is the register is the U0IIR, that means the UART0 interrupt identification register. This is the 32-bit read-only register. In that the interrupt identification register, it provides the status code that denotes the priority and the source of the pending interrupts. It must be before the existing service routine to clear that the interrupt. If the bit 0 is the interrupt ending, it is the 0, at least the 1 interrupt is the pending, and it is 1, there is the no interrupts pending. The third, the 1 to 3 bits bit are the interrupt identification. If that the identifies the interrupt corresponding to the UART 0, that means the RXFIFO, whereas this bit is the 0 1 1, it is the receive line status interrupt, where this bit is the 0 1 0, it is the receive data available interrupt, where this bit is the 1 1 0, that is the character timeout indicator interrupt, and this bit is the 0 0 1, there is the THRE interrupt. Their next bit is the 6 to 7, that is the FIFO enable bit. These bits are the equivalent to the FIFO enable bit and the FIFO control register, whereas the 0 if the FIFO are the disable, and where bit is the 1, there is the FIFO are that the enabled. The next is the bit number 8. The bit number 8 is the AB0 interrupt. If the interrupt is enabled, therefore the 0 no ABE0 interrupt, and therefore the 1 it is the auto baud has the finished successfully. The bit number 9 is the ABT0 interrupt. If the interrupt is enabled, there this bit is the 0, there is a no ABT0 interrupt, and their bit is the 1. This is the auto baud rate has that the timed at the out. The next is the UART0 line control register. If this bit is the 8-bit read or the write registers, it determines the format of the data character, and that is the transmitted or that the receiver. Therefore the bit 0 to 1 is the word length selector. If this bit is the 00, it is the 5-bit character length. If it is 01, it is the 6-bit character length. It is 10, it is the 7-bit character length. It is the 11, it is the 8-bit character length. The bit number 2 is the number of stop bits. If it is 0, there is the 1 stop bit. If it is 1, there is the 2 stop bits. The third bit is the parity enable. If it is bit 0, therefore the disable parity generation and that checking, and if it is 1, there is the enable parity generation and that for that the checking. The bit number 4 to 5 is the parity select. If it is 00, there is the odd parity. If it is 01, there is the even parity. If it is 10, it is forced that the 1 stick parity, and if it is 11, therefore the forced 0 stick parity. The bit number 6 is the brake control. The bit number 6 is the 0, therefore the disable brake transmission, and if it is bit 1, therefore the enable brake transmission. Bit number 7 is the divisor latch access bit, that is the 0, therefore the disable access divisor latch, and the 1, that is the enable access divisor latch. The next is the register UART0 line status register. It is the 8-bit read-only register where it provides the status information UART0 RX and TX blocks. The bit 0 is the receiver data ready, that means this is 0, therefore the receiver data empty, and the 1, it is the contains valid data. Bit number 1 is the overrun error. This is the 0, the overrun error status inactive, and this is the 1, the overrun error status active. Bit number 2 is the parity error, whereas the 0, the parity error status inactive, whereas the 1, the parity error status active. This bit is cleared when the U0LSR is the read. The bit number 3 is the framing error, where 0, the framing error status inactive, where 1, the framing error status active. This bit is cleared by the U0LSR is the read. Bit number 4 is the break interrupt, where it is 0, the break interrupt status inactive, and the 1, the break interrupt status active. Therefore the bit number 7 is the error RXFIFO, that is the bit number 0, the U0RBR contains the UART0RX error, and this bit is the 1, the U0RBR contain at least one UART0RX error. This bit is cleared when the U0LSR is that the read. The next bit is the UART0 transmit enable register. It is the 8-bit read or that the write register, whereas the U0TR enable implementation, the software flow of control. When the TXEN is the 1, UART0 transmit the sending data as the long they are the available, and that the as soon as the TXEN becomes the 0 and UART0 is the transmission will stop. The software implementation, software handshaking can be the clear bit and the receive the X0FF character. The software can be bit again the receive the X on character. The bit number 7 is the TXEN, whereas the TXEN 0, the transmission is enabled, and the TXEN is the 1, the transmission is the enabled. If this bit is clear to the 0 while the character being sent, and the transmission of that the character is completed, but no further character are sent until to that the bit is the set again. The programming of the UART is the first one is the initialization of the UART that means the configure the pin P0 and the P01, that is the corresponding bits of the PNL. And that is the second is the receiver character. Third step is the transmitter character. In that the second step, receiving character, it is the monitor to that the RDR bit, whereas the U0 LSR register to see the valid data is available into the U0 RBR register. The third step is the transmitting character, whereas the monitor, the THRE bit is the U0 LSR register. When this bit is the becomes 1, it is indicate that the U0 THR register, and that the empty for that the transmission is that the completed.